Good morning. Welcome to Wednesday. Good morning, Joey. Good morning, Alexa. How are you guys doing today? It's Wednesday, halfway through week 5. Homework's due tonight. How are your other classes? Are you guys surviving your other classes? What else are you guys taking? Let me know. I'm curious. I think most of you guys are freshmen. Couple sophomores. Occasionally there's some juniors and seniors. Oh, you guys have physics. Physics. Let's see, Physics 107. You guys are learning vectors and like shooty problems, the arrow problems. I hated those for some unobscure reason. Physics 1. It wasn't challenging for me per se. It was just, it took a little bit longer to go through the problems and mentally think through what's happening. That was my husband and I, we went to engineering school together. We were different majors, but we took physics together. And Physics 1, that first test, that was the only test he beat me on, and he still rubs it in my face. What is it, 2009, 12 years later? So good luck on physics. Should be fun. Yeah, just mentally figuring out what's going on. I always found that drawing pictures in physics really helped. Trying to sit there, especially for Physics 1, for the mechanical stuff. Visualizing it, drawing pictures really helps. Morning, Zanzib. Adil does not like physics. Yeah, it happens. Alexa, statics. Statics also, that one's also a little challenging. It tends to be a lot of information. Once again, pictures, really helpful. Statics is like mechanical physics on crack. It's just, it's nice because things don't move, but it's just, there's just a lot of equations, a lot of solving everything. Yeah. DiffyQ, CE220. What's CE220? Is that computer engineering, civil engineering, biotech? Oh. Would not have guessed that. Chemical. That's the other C. I knew there was another C. Chemical. Oh my goodness. Chemical engineering sounds like there's just chemical and mechanical engineering. Those two engineerings kind of scare me a little bit because a lot of it's so many equations. Like, it's just so heavy on the fluids and the dynamics, and there's just so much in those two specifically. Yeah, I'm not gonna lie, my fluids class, oh, good luck, Holly. It'll be great. Motivation and, if you have some sort of meaning behind things, then it really helps, but they're fine. They're just so equation heavy. It's intimidating to me. And so, but you guys can do it. Cool question for the homework. Is the third question? Yeah, the third question is just a huge matrix. So don't worry about, so a lot of you guys are indexing the matrix. When I solved the problem, I literally just typed in A. So A equals this value, this value, this value, this value, this value. Next line, this value, this value, this value, this value. So you type in A, you type in B, and then you just solve for F. F equals A, left divide B. That's it. It's technically, you can do it in 3 lines of code. A is just really long. Electrical and chemical scare me. Electrical, My favorite part of fluids was when we related it to electrical circuits. I love circuits. I love programming. My background is biomedical engineering. If I had to do everything again, I would probably do more of a computer engineering or electrical or software, something along those lines. CAD, yes, CAD. Okay, so it is 9:10. I loved our little discussion. I don't know, I like learning about you guys. Tell me about yourselves. But let's go ahead and jump into class. Also, if you want to ask me questions, anything really, the worst thing I'm going to say is I'm not going to answer that question. So if you guys ever want to ask me questions, feel free. I like interacting with you guys. It's fun. It's the best part of my job. Okay, let's jump into the material for today. So there we go. On Monday, we learned about two different functions. We went a little slower than I wanted to, but we learned about the input function, where we're going to use input when it says prompt the user. That's a focus on input function. When we use the input function, we literally just type variable equals input and then enter in our prompt. You can use single quotes, you can use double quotes. I'm going to demonstrate it in single quotes because I find you'll probably run into the least amount of errors using single quotes, but it shouldn't matter. They do mean two different things though. If you're expecting numbers or numerical data, you would just leave your prompt like that. If you are expecting text data, if you're expecting the user to enter in some sort of words, you would add in this additional option for with this S here. Once again, single quotes should be fine. Double quotes also should be fine. Just note, those two aren't the same, so I'm going to demonstrate it in single quotes. But here's your two options. We also talked about disp, the disp function, or short for display. We have less control over how we want things printed out using display. But if we're just going to display some text, so display, print out text here, whatever we type here will be printed out to the screen, followed by a new line. So there's an implicit new line. If we want to combine text and numbers, we would say disp bracket, and then we'd enter in our text, some variable, and keep going until it's combined. If this variable is a number, we need to use num2string. And that's what we talked about on Monday. Yes, there are office hours after class today. There's always office hours after class. Has there not been? Yes, there are. I will see everybody who wants to come to office hours after class. Okay, so today we get to start talking about the fprintf function. I'm not gonna lie, there's a lot when it comes to fprintf. Fprintf is a magnificent, glorious function, but it's complicated. And it's not necessarily complicated in the sense of how to use it per se, it's just complicated in the sense that there's a lot of options we can choose from. So, with the display function, we printed out this text. I want to go ahead and repeat that, except using the fprintf function. So a couple notes before we type it into MATLAB. Fprintf, you literally just type fprintf. And then you have a string, just similar to display, except anytime we want to enter text or enter variables, enter numbers into the string, we use a % followed by what's called a conversion character. Okay. So let me go ahead and demonstrate this. So if I want to print out this first line of text using fprintf, I'm going to type in this string for a flow of, and then here I want to insert some data, and then followed with the string with a density of, and then insert some data, kilograms per meters cubed, and a whatever, and then a new line. Nope, not what I wanted. So in fprintf, it looks like this. I type fprintf, single quote on both sides, and then I just type in my text. For a flow of, I'm going to insert something there. I'm going to mark it there with underscores. With a density of, once again, I'm going to insert something, mark it with underscores, kilogram per meter cubed, and A. I already have that. So this is where I start with fprintf. I type in the string that I want to print out, and then wherever I'm going to insert some data, something from a variable, I just marked it here with underscores. I'm going to replace these underscores now with this idea, where I put a percent sign followed by a conversion character. So here I insert a percent sign, here's a percent sign. Here, I'm going to insert a variable that contains text. So if you're going to insert a variable that contains text, you're going to follow with %s. So here's for text variables or string variables. So you insert a string, %s. Here, I want to insert a variable that contains a number. So there's a couple options for numbers. We can insert integers with %d or %i, either one. I like %d just because it's old school. %i also works. So here's integer variables, integer variables. I always add an extra r in integer. Or if it's not an integer, so non-whole numbers, go away. It's %f. Non-whole numbers. So to be honest, this one and this one is essentially where you're going to live. That's where what you're going to use most of the time, %s and %f. Occasionally you can use %i, but there's less chance of your variables being exactly integers, and it turns out you can manipulate %f to appear as an integer. Okay, but those are my options. So this number here, my row, whatever that is, my density, it's going to be a non-whole number typically, so I'm going to put in a %f. Okay, there we go. For a flow of insert some text with a density of insert a number, kilograms per meter cubed, and A. Now I need to tell it where those variables are going to be located, or where that data is going to be located. So the %s corresponds to my variable called type, and we typed that in on Monday. And the %f comes from the variable called row. So type corresponds to this %s, row corresponds to this %f. Okay, so it looks very similar to what we did with display. This is what we did with display. We typed for a flow of insert some data with a density of insert some data, kilogram, meter cubed, and A. For fprintf, it looks like this though, where everything's in one string, where I use percent signs to indicate insert some data here. The data that's inserted then comes after. Okay, so let's go ahead and run this code. So here's what it looked like with display. I'm gonna comment that out. So here's what it looked like with display right here. Here's what it looks like with fprintf. Display automatically enters in a new line after it prints out the text. For fprintf, we can just insert it, we have to manually insert a new line using \n. So here it controls our white space. So for fprintf, it prints out for a flow of insert some data with a density of insert some data, kilogram, meter per cubed, and A. And then it explicitly, we enter in a new line. We have to do this with fprintf. It does not do it automatically. Okay, so there we go. It prints out for a flow of gasoline with a density of 735. When we use %f, it automatically prints out 6 digits past the decimal point. We can change that. I'm going to show that later. Okay, so there's my first line with fprintf. Woohoo! First line done. Now I want to do my second line. So once again, fprintf, velocity of insert some data. This is a number, so %f, meters per second, the pressure drop across the enlargement, \n. And there's my next line. Let's say I didn't give it a variable. So first things first, MATLAB gives me this underline that says the format might not agree with the argument count, which means you're probably missing some data. If I ran it, where are we? So it still works. It will not give you an error. It will just stop when it gets to the %f. Okay, so it's not the end of the world if you forget something. Once again, just make a change. Be like, oh, I forgot to tell it where the data is. So this %f, the data that's inserted here comes from the variable v. Okay, run it again. Here we go. For a flow of gasoline with a density of this number and a velocity of this number, the pressure drop across the enlargement. Once again, we see with %f, it's printing out automatically 6 digits past the decimal point. And like I said, we can control that. Just not, I will show you in a minute. Okay, so I've got that second line printed out. Third line, fprintf, as a function of the diameter ratio is \n. I didn't insert any data here, so I don't need any variables. Run it. There we go. We can see I have now printed out those first 3 lines using fprintf. So for display, you need to do that in 3 lines of code because you need 3 new lines. We can't type the new line character in display. It's just automatically going to appear. It's implicitly at the end of every time we use display. For fprintf, though, technically, I could type this all in 1 line of code. fprintf, this one, followed by this, followed by this. So technically, I can type this all in 1 line of code, where I say for a flow of insert some data with the density of insert some data and a insert a new line, velocity of insert some data, meters per second, the pressure drop across the enlargement, insert a new line, as a function of diameter ratio is insert a new line, and then I would give it all of my variables. Type, row, and v. So here, this is 1 line of code. For display, though, you need it in 3 lines of code. Does row and type need to be defined beforehand? Yes, always. Anytime you're using your variables, they need to be defined beforehand. So I can't say that, I can't use type in this line of code, but then define it later on. MATLAB's gonna be like, I don't know what type is. You didn't tell me. What does type store? I can't insert any data that doesn't exist. So good question. Okay. So like I said, we can have more control over our numbers. So let me go ahead and go back to our notes. So for fprintf, we've got this %sign, and we have this conversion character. So I'm going to call it C. Between those two, MATLAB gives us 2 options. Well, technically there's 3 options, but I'm going to focus on 2 of them because the 2 of them are more useful. And they're separated by a period. So option here, 2 options. These are all optional, but they give us more control over how our numbers are going to be printed out. The more useful, or the more one that's used more often, is this one, where we can enter a number in here that indicates how many digits past the decimal point we want to be printed out. So digits past decimal. So it's always following the period. So if we go back to our code, and I see this %f, let's say I want to print out 2 digits past the decimal point. I just say 0.2 or period 2. So between my period, or between my %sign and between my f, I just say 0.2. Same thing here. Let's say I want 3 digits past the decimal point. I just say 0.3 between % and f. So now when I run it, we can see that the number of digits past the decimal point changes from 6, as it was here, to 2. Here it was 6. Here it's now 3. I'm going to comment these out. There we go. If I wanted it to be 0, so I wanted this to appear as an integer, I would put in 0. Same thing here. If I wanted it to appear as an integer, I would put in 0. So now we can see there's no digits printed out past the decimal point for either number. Okay. So you want to use the number that makes the most sense for you. If you're expecting integers, if you're expecting whole numbers, feel free to use the %0f instead of %d or %i. There are some caveats to %i. It doesn't always work if the number isn't an integer. So I like using the %0 or %.0f to enforce that it appears as an integer instead of using the %i. So that's what I mentioned. That's why I mentioned %f and %s are kind of your wheelhouse. That is my first optional number, and that makes the most sense to use when you are printing out text and numbers at the same time. Okay, the second option here is called the width, more specifically the field width. It's also a number, and it indicates how much space you want to take up. So Zanzib, what do you mean by truncation? Like rounding the number, or? Because you can always use the round function. That's totally fine. So if we go back to our notes with MATLAB, I could always use %d or %i and just make sure it's always rounded to 1 digit or something. That's completely fine as well. There's multiple ways to do things when it comes to programming. Pick one that makes sense to you, and that's fine. So like I said, this second option here is the field width. Not that one. This one. It indicates how much space to take up. So if I look at this number here, this takes up 1, 2, 3, 4, 5, 6 spaces by default. If I wanted to take up more spaces, I can change this here to be 10. And so instead of it taking up only 6 spaces, it would essentially add extra white space to take up at minimum 10. So here we can see I take up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is the field width of that number. It's always going to be right justified in that field width. And this is really helpful when it comes to tables. So let's go ahead and print out our table. So the next thing I want to print out is this here. I want to print out my table. I want to print out my table here, just like I did with disp. So first things first, fprintf. Let's print out my header line. So diameter, pressure drop, new line. And once again, same thing as it was with disp. We don't know the spacing yet. Just try something, start with it, make it changes as you go on. fprintf. Oh, I could do these in one line now. N. And then ratio PA. Woohoo! I can do that in one line of code. Okay, so here we can see what it looks like. Hey, I didn't do too bad with lining that up. I don't know exactly how far my numbers are going to be in yet, so I'll just leave that there and just wait. Okay. Now, the next thing with fprintf is printing out a table. With display, it looked like this, where we just put our numbers in a matrix and printed out that matrix. And we used format, whatever, to make sure it displayed properly in the command window. For fprintf, we have explicit control over how we want to do things. So I'm going to start with fprintf. I have my open quote, close quote. And then I'm going to go back to my piece of paper here. So when I'm printing out a table with fprintf, essentially you want to figure out how one line of code works, or what you want one line of your table to look like. So here I have one line of my table. This should be a period. So this first number, I'm going to use %f. This second number, I'm going to use %f. But then you can play with these options. You can play with these options down here. So it's going to be %f, %f. It's my first line. first set of numbers in my table. %f, because I'm printing out a number next to a number. So now you want to play with these options. Figure out how many digits past the decimal point you want printed out. I want 1 digit past the decimal point printed out for my first number. And then for my second number, I want 2 digits to be printed out. On my document here, you can see that's how it's stated. So I'm going to choose those. Then you want to figure out how far apart your numbers should be. And start with something. Start with like 10. What these do is these allow you to align your numbers. So let's go ahead and put that in. %10.1f followed by %10.1f. You can put in a space there if you want in between the numbers. That's fine. It's not going to make that big of a deal. It's just added spacing. Okay. And then at the end of printing out, I want to press a new line because I want my data to end. So I want it to go to the next line. So when printing out tables with fprintf, you're going to identify how do you want each line to be printed out. For this set of data, I want them to be spaced 10 apart. I want 1 digit past the decimal point, followed by another number that's 10 spaces apart with 2 digits past the decimal point, followed by a new line. Then what you are going to do is you are going to create a new array with your numbers that you're going to print out. Identify what you want to be in the first column. I want my first column to be R, the values in R. And I want my second column to be the values in del P. When we use the display function, we want them to appear exactly the way we want them in the table. We want R to be a column and del P to be a column. With fprintf, for some odd, obscure reason, the rows in this array are going to be our columns, and the rows in our array are going to be columns. So R should be my first row, and then del P should be my second row. I don't know why, that's just the way it is. Display, we want them to appear exactly as they are, so as columns. For fprintf, we want to make sure that they are in rows. It's just one of those annoying nuances to remember when it comes to programming with MATLAB. So now the values in R are going to be printed out for this, and the values for del P are going to be printed out like this. If I do R del P, it looks like this. This is what my matrix looks like. Format short G. It looks like this. So what fprintf does is it's going to repeat this structure until all of these numbers are gone. So it's going to use this for the first number, and then this for the second number, going down in a column. That's just the way it is. Okay, and we'll go through another example of this. fprintf, when it comes to printing out tables, is probably some of the most complicated ways to use it. It's harder to wrap your mind around. So if it's not making sense right now, that's completely fine. I don't expect it to. We will go through another example, and I will probably have a supplementary video as well going through another example because it's hard. But fprintf, when you're printing out a table, you want to make sure that you identify in your string there, in your single quotes, how you want each line to appear. So for this table, I want a number followed by a number and then go to the next line. And then in this array, you put your first column of numbers as your first row, your second column of numbers as your second row, because fprintf is going to go through that array number by number, column wise. Okay, so when I print it out, it looks like this. Once again, things aren't exactly aligned properly, so you can go ahead and play with the spacing on your header, which is fine, or you can play with the spacing on these options. So let's say I don't want this to be 10, I want it to be 5. I can run that, and we can see now instead of it taking up 10 spaces, it takes up 5 spaces. If I wanted it to be 0, It would be all the way along the edge. So at minimum, it needs 3. So it will take up as much space as it needs. It will just add more as you tell it. So I want it to go, let's do 6. And then I'm going to, hey, there we go. It mostly aligns. I want these numbers to be over a little bit more, so I'm gonna make this bigger. I'm gonna make it 15. A little too much, so I'm gonna make it 13. Not quite, so I'll make it 12. I can also add spaces to this and push things over. Let's make it back to 15. So we have more control over how we want things printed out with fprintf. With display, we needed to use the, sorry, I don't see it. With display, here we go. We don't have any control over the spacing. We have to use the format command in MATLAB in order to print out the numbers. So here's format short g. If I did format, it would print it out differently. Whereas fprintf, it will appear the same every single time. Okay. There we go. That is fprintf. Like I said, there's a lot in fprintf. It's not complicated in the sense of how to use it per se. It's complicated in the sense that there's just a lot of options. But it's really nice because it gives us explicit control over everything. Every variable that's printed out, every white space, we have to use new line, whereas display, it prints out numbers however it wants to, it automatically puts in a new line, and so you use the one that best fits your application. Sometimes I like using fprintf. Sometimes I'm just like, display's a little bit easier, so I'll just use display. Okay, let's look at load and save. Okay, let me open up a new script file. Save it. Week 5 examples 2. Clear CLC. Yes, I did mean CLC. Okay, let's do another example. This one, though, we are going to use load and save. So here, this prompt, this homework document, essentially it's an old homework, says import the data from the silver.dat file using the load function. So that's a pretty good indicator that you need to use the load function. So load. When we are loading in data, we literally just type load, followed by the name of our file. So it's called silver.dat. That's it. That's all you need to do when it comes to the load function. This is one of the ways to use it. We can also use it as a more traditional function. So load, open, close parentheses, and then silver.dat. So these are 2 ways to use the load function. Either one works. This is a little bit different from what we're used to, but it works. This one also looks more similar to what we're used to, where we type the name of our function followed by open, close parentheses. Just keep in mind your file name needs to be in quotes. File name in quotes. Okay. That's it. That's load. Keep in mind when we are loading in data, it needs to be a .dat file, a .txt, a .mat. These are essentially our options, but it needs to be either a .mat file, which means it's specifically a MATLAB file that stores data, or it needs to be text readable. You should. When it comes to all of these functions, you should use a semicolon afterwards. Some of them will print out stuff to the command window. If you don't use it, some of them will. In general, though, moving forward, put a semicolon after everything, after every line, and then use display in fprintf when you are explicitly wanting to print something out. So you don't clutter your command window. Because as you get to more complicated code, the more, if you leave semicolons off, the more it's going to be printed out to your command window. And the more that's printed out to your command window, the slower your code is going to run. So in general, always put a semicolon, use display in fprintf to print out explicitly what you want, as opposed to implicitly leaving the semicolon off. Okay, There we go. Use load. Also keep in mind when you are loading in your files, loading in silver.dat, that file needs to be in your current folder. So you can see in my current folder, I have a file called silver.dat. If you did not have that file, MATLAB would say, can't find file, and give you an error. But either one of these will work. When I run it, in my workspace, now I have a variable called silver. If you notice, silver is the same name as my file name. So the load function is going to load in this file, create a variable with the same name that stores the data. And if I open up silver.dat, if I open it in MATLAB, it looks like this. Notice it contains a square set of numbers. Your files should contain a square set of numbers. And then if I open up my workspace, I can see it contains the same numbers. They're formatted simpler to read because this is in scientific notation, but it's the same numbers. And then I can just use silver in any way I want. So one thing to note is when you are loading in data from a file, it's going to be all numbers. So it's not going to be combining text with numbers, it's all numbers. And you need to have some information about what that file contains. So this silver file contains, the first column is temperature in Kelvin. So temp in Kelvin. And the second column is the specific heat in calories per mole Kelvin. One other thing to mention is for the load function, if you do not want your data to be saved in a variable the same name as the file, you could say a equals load silver.dat. And instead of it creating a variable called silver, it's going to store the data in a variable called a. Okay, but this is how you would have to use that. So now a contains my data instead of silver. Yeah, but either one works. It's up to you. You have the freedom as long as you know what your variable is named. Okay, so now I can use this data. Let's say that I want to split it up into columns. So my temperature is silver, all rows, column 1. So here's my temperature, data in Kelvin. And then my specific heat is silver, all rows, column 2. Here's my specific heat in calories per mole Kelvin. And let's say I want to convert this data. I'm not going to go through that. There we go. And let's say my goal is to convert this data. I want to convert my temperature. Oops, forgot my temperature calculations. There we go. So here, I'm converting my temperature calculations from Kelvin to degrees Celsius. And then here, I'm converting my specific heat calculations from calories per mole Kelvin to joules per mole Kelvin, and then joules per gram Kelvin. So I'm just doing some unit conversion, not that big of a deal, but that's what that does. So now I've done something, I've changed it. I've used my operations. Now my last thing is to save the converted results into a file called silverconverted.dat. So import the data means use the load function. Save the data means use the save function. Save and load look very similar. Load silver.dat or load silver.dat, either one works. Same thing with save. I can do save and then whatever file name. Silver converted.dat or save silver converted.dat. However, when we save, we need to identify which variable we're going to save. So do I want to save A? Do I want to say silver? Oops. Do I want to save my converted data? Somewhere I just need to tell it which variable I want to save. A lot of the times you're going to create a new array that contains your data that you're going to save. So results is going to be the array that contains all of my results. So it's going to contain my temperature in degrees Celsius in the first column, and then my specific heat in joules per gram Kelvin in the second column. So I want to save the results in TOC, and then SHJPGK. So just like you do with display, you're gonna create an array that is essentially exactly how it's gonna look in the file. So that when you say save, you're going to identify that it's going to be the variable results. So the data stored in this variable. Same thing here. You're just gonna identify that it's the data stored in the variable called results. Once again, we are talking about saving data in a .dat file, a .txt file, or a .mat file. If you're saving it in a .mat file, this is all you need to do, you're done. If you're saving it in a .dat or a .txt, you need one additional option. You're gonna do -ASCII, or here, -ASCII. So both of these do the same thing. The -ASCII, this is ASCII, and it just means that it's going to make sure that these numbers are text readable. It's going to make sure these numbers are stored like this, because if they're not, it's going to default to the MATLAB encoding, the file structure for MATLAB, which is not opened in a text editor. Okay. So here we go. I run my code, and now in my current folder, I have a file that shows up called Silver Converted, and it looks like this. It contains all of my results. And if I open up my results variable, it's the same numbers, just not in scientific notation. Okay, if we did not have that ASCII option, if I left this off, it would look like this. It looks like a bunch of garbage. Where you'll see it says MATLAB 5.0 mat file. Its default is to do the mat file encoding, which is not readable in your text editor. It's kind of like trying to open up an Excel file using Notepad or TextEdit. You get a whole bunch of gobbledygook that is encoding that's only read by Excel or by Word. And so we need to make sure that we have the ASCII option when we are saving a .dat or a .txt file. I like txt files because it's text. A .dat is just a data file. There we go. So load and save are a little bit simpler. Load, it doesn't matter what kind of file it is. We can say .ascii or dash, come on, to indicate that it's an ASCII file that's being read in, or a number readable, a text readable file, but we do not have to. It will automatically detect that it is and be fine. When we do save, we need three things: the name of our file, the variable that stores our results, and then the ASCII option. If we're saving in a .mat file, we technically only need the file name, and it will save everything in the workspace. A .mat file, like I said, it's only a MATLAB file, so it can only be opened in MATLAB. It's less usable, however, you can use it. I used one yesterday. But in general, typically we're talking about DAT files or TXT files. If you're dealing with spreadsheets, there are some very nice ways that MATLAB can read in data from a spreadsheet or write data to a spreadsheet. That is beyond the scope of this course. If you are interested in that and want to know, I would be fine talking with you about it during office hours, or email you some things to look up. But there are better, more sophisticated ways to import data in MATLAB. It's just we're not going to go over those in this class. Okay, so load and save. Input. Those three are fairly straightforward. I'm going to go over some more disp and fprintf practice. So here's my data. Let's say that I want to, in addition to saving it, let's say I want to display it to the screen using disp. So let's say I want to print out this table to the screen using disp. So once again, for disp, I can print out my first two lines. So here's my header, temperature, OC. I don't think there's a more advanced version of this class. Matt, that's a good question. This is the only MATLAB, explicit MATLAB class that I know about. MathWorks has tutorials that you can go through and do on your own time, but there is no EAS elective. It's a good idea, though. Maybe I'll petition it. I love teaching new classes. That'd be fun. Anyway, I don't know if there's space for that, but no, there is no, not that I know of. Okay, so let's print out my first two headers. So the first one, temperature and specific heat. There's my first line, disp. Come on, fingers. OC. I line that up. So it's going to be, according to my document, I want it to be immediately between the PERA, so I can line it up manually. And then my specific heat underneath the E. I want my bracket, joules per gram Kelvin. Okay, there's my first two lines. Now, for display, I'm just going to create a new array where my temperature is in my first column and my specific heat is in my second column. So display, temperature, OC, placed immediately next to SH, JPGK. Remember, it's a new array, so I need my brackets. So when I print it out, ooh, error. C is capitalized. There we go. It's printed out. Once again, I don't have control over how display spaces everything. However, it's a nice way to just easily print things out. It's 3 lines, nice and simple. And then I can space things out manually to align my header. So let's say I want this negative to be under the P. So I can space it over 3 or something like that. Run it again. Lines up a little bit better. Move it over more. Run it. It lines up. There you go. Let's say I want it lined up like that. If I wanted to do the same thing with fprintf, it would look like this. Temperature, specific heat, fprintf, OC, joules per gram Kelvin. And then, same thing as I did previously, fprintf. I'm going to identify how I want each line to appear. So I want this first number to be a number, so %f, followed by another number. So this one, %f. I want this first one, sure, 2 decimal points. That looks pretty good, so I'll put 0.2. I want this one to have 4 decimal points, so 0.4. And then I want it to take up, I don't know, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 spaces. Put in a 10. I want this one to take up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It takes up 13 right now. I want them to be a little bit farther apart, so maybe 15. Followed by a new line. And then I'm going to create an array where my temperature is the first column, or first row, so TOC, transposed, followed by my specific heat as a second row. So SH, JPG, K, transposed. So note, display, you want things to be as columns. For fprintf, you want them to be as rows. Okay, run it, see what that looks like. Ooh, notice, I messed up here. I forgot some new lines. So I'm gonna put in a new line at the end of that, and then a new line at the end of this one. Make a change, run it, see what it looks like. Okay, there we go. They're lined up. I want to space things out, or maybe I want to just reduce spacing here. So I'll make this 8 instead of 10. Run it. So now my numbers are much closer to the edge, which maybe you like that, maybe you don't. And then I want to space out specific heat. So space this over more, space that over more. Run it, see what it looks like. Not quite, a little too far. Reduce it a little bit. Run it, see what it looks like. There we go. It's nicely centered. So here's what it looks like to print out the table using disp. Here's what it looks like to print out the table using fprintf. Let's say I also want to use fprintf to print it out like this. So here's an example where we can only use fprintf to do this, at least nicely, in one line. So let's say I want to print out this line of text for every single set of values. For T equals insert some number, degrees Celsius, comma, specific heat of silver equals this number. Joules per gram Kelvin. This is just a table. This is just a table where each line, I want it to look like this. For T equals, insert some data, %F, 0 Celsius, specific heat of silver equals, insert some data, joules per gram Kelvin. New line. So now, instead of my table just being numbers, each line in my table is going to contain this text. Same thing though, my data is going to be in an array where the first number is going to be in my first column or my first row, so TOC transposed. And then my second number here is going to be in my second row. So SHJPGK transposed. Close it off. There we go. So now it takes out, or it prints out for every single set of values, each line. Whoop. Go away. So now instead of my table just containing numbers, it contains this whole clunky text. So with fprintf, we have a lot more control over how we want things printed out. I couldn't do this with display easily. You can, it would require a little bit more creativity, or a lot more lines of code or loops, as we'll learn in 2 weeks. But here I can easily print this out using fprintf in one line of code. And I can change it. I can say that I want each of these numbers to be 2 digits past the decimal point, 0.2, and maybe take up a spacing of 1, 2, 3, 4, 5, 6, 7, all of them to take up a spacing of 7. This second number, let's say I don't care about the spacing, I just want 4 digits past the decimal point. So now we can see they're nicely aligned here, and it's much cleaner. I don't know what you mean by only function, but yes. In this instance, display, we want it to be in columns when we're printing out a table. In fprintf, we want to print it, or we want them to be in rows when we're printing out a table. And I mean, if you didn't do that, they weren't in rows, it would just look funny. So let me show you what it would look like. So here they're in columns. So it would just print out like this. So it would print out all of the first column first, and then all of the second column. Yeah, so Aurora, yes. This will be the only one where it's backwards that we know of, I believe. But when you're printing things out with disp and fprintf, just remember everything is printed out character for character. Display, here we go. Display inserts that implicit \n. It's in there, it's hiding, it's in there. So just see what it looks like in the command window and adjust as you need to. Be like, oh, this table isn't correct, so let me transpose it, see what happens. Okay, now it's normal. It's what I expect. So just try something, change it. Try something, change it. If the spacing doesn't work out, move it. Move it. Try something. So there's a lot of give and take, a lot of back and forth. Experiment with things. Just know the basics of display when we want to. Here we go. Oop, wrong one. Display when we want to combine both text and data. We need to put a bracket, and then we quote around our text, and then insert our variable. Quote around our text, insert our variable. If that variable is numbers, use num to string. For fprintf, if we're inserting some data, use a %s. If it's text, %f. If it's not text, or if it's numbers, indicate which variable that you want to insert. How many digits past the decimal point? How much space do we want it to take up? Try those different options, play around with it. It will print out in your command window and adjust as needed. There are additional options for fprintf. They're in the notes. Like if we want scientific notation, we can use %e. If we want to choose between floating point and scientific notation, we can use %g. I encourage you guys to focus on S and F as your starting point. And as you get more used to things, as you get more complicated, you can introduce some of these additional letters. But yeah, I will go over, I will create a video that is one more example that start to finish in a video. It should be about 5 minutes, hopefully, I don't know, maybe 10. I will post that on UB Learns later today, so that you guys have another example. Other than that, that's our material. So we're focusing on these 5 functions: input, display, fprintf, load, and save. Okay, I gotta run to office hours. Any final questions before we end? Okay. I will see you guys next week. You got it. Week 5. We can do this.